This reference design is for a 3-wire ultrasonic product. It includes everything from schematics to assembly instructions and firmware to behavior control.
Rollout. We share hardware reference designs for robotics so you can make your own hardware.
Hi there, welcome to Rollout. I'm Jeremy, and today we're rolling out the E-18 Ultrasonic sensor. This ultrasonic sensor includes a 3-wire interface. It does distance measurement as well as proximity and collision detection, and it also has an onboard voltage regulator. Okay, let's connect the ultrasonic sensor to EasyBuilder. First, we need an EasyBuilder compatible board. I have an E-18 here. Next, let's connect up the ultrasonic sensor. Connect port D0. There we go. We'll connect to the Wi-Fi address, the E-18. Connect an EasyBuilder here. Okay, we'll add the behavior control by going up to the top left corner and then going over to the right and clicking ultrasonic. And let's do distance control. So we'll need to go into the settings, click the gear icon, and change the trigger port to D0, and also the echo port to D0 because this is a 3-wire sensor. Both trigger and echo are on the same port. Save that, and then we'll just unpause it. We should get some values. There we go. So if we point this up to the roof, it should be a pretty large number. It's jumping around a little bit, probably because my hand isn't very steady. But if I put my hand in front of it, you'll see the values go really low. And as I raise my hand up, it'll increase the values. As long as my hand is in front of it, which I'm probably not doing a great job of aiming it. There we go. Pause that. Next, let's add a radar control. So we'll have to set this up as well. Trigger port will be D0, as well as the echo port. And let's do the servo port as D1. So we're going to add this little jig here. This will give us our radar values. Just put our ultrasonic sensor in there. Secure it. Okay, and then we'll put it out there. Okay, we'll save our behavior control. And then once we select unpause, it should start moving. So it'll pick up probably a lot of the camera stands and stuff around here. You can see picking up probably some of the walls as well. So anything closer to this bubble here is closer in range. All right, if we wanted to, we can actually change the minimum distance and also the delay in the turn. We can also change the scanner interval, make it a little faster. There we go. Next, let's do an example that involves the collision detection behavior control. In order to show off collision detection, we'll need a robot. So I have this 3D printed robot here that'll work as a great example. We'll go up to the top left and add controls. Go over to the right, ultrasonic, and then click the collision detection behavior control. To set this up, we'll go to the gear icon and select D2 as a trigger port and D2 as the echo port, because that's what we're hooked up to on the robot. We'll change our minimum distance to 10 here, because we don't have that much room on our table. Next, we'll have to make note that motor control ports are set from a movement panel. So this robot has 2 continuous rotation servos, so we'll need a movement panel that can control them. And you can find that on the right here in servo, continuous servo movement panel. So we'll set this up to be D0 on the left servo and D1 on the right. Save that. We'll have to increase the PWM sliders here a little bit so we have a little bit of speed. And then we'll connect to the I/O-Tiny. There we go. So I'll deselect this pause button here on the control, and you'll see the ultrasonic value. Now this robot will stop once we hit forward, if it hits a value of 10 or below. So let's do this. There we go. It hit 9 and stopped. So that was an example of using a 3-wire ultrasonic sensor for collision detection. Next, let's look at the schematic. Okay, here's the schematic. First off, we have our voltage regulator that takes in the voltage input and converts it to 5 volts for our circuit. Over here is a non-populated programming header. This is our header that connects to the HC-SO4 ultrasonic sensor. This is our output port. Down here we have our indicator LED, which lights up when there's something in front of the ultrasonic. And this is our microcontroller, which is a PIC 16F1704, which takes the signals from the ultrasonic sensor and gives us a single output. Here's the bill of materials. First off, we have the PCB. Next, we have the PIC microcontroller, and then the ultrasonic sensor itself. We have a 5-volt regulator, and some caps and resistors, and a pin header that connects the output port. And lastly, we have the red LED. One thing to note is that the PIC microcontroller does require custom firmware, and we provide that on our GitHub page. Here are the assembly instructions for the ultrasonic sensor. First off, you want to trim a single pin, and that will stabilize the PCB. Next, solder on the output port. And lastly, solder on the ultrasonic sensor to the PCB. That was the E-18 Ultrasonic reference design. Find the links for the Synthiam behavior control and the GitHub reference design files in the description box below. And don't forget to subscribe so you can get notifications for our next rollout videos. Over and out.
Thank you for watching Rollout. For more information, visit www.synthiam.com.